Thank you to Twingate for sponsoring this video. In previous videos, I've talked about different ways to access Home Assistant, from Cloudflare to Nabu Casa to DuckDNS to Nginx Reverse Proxy and maybe others I can't even remember. But today I want to talk about Zero Trust networking and a company called Twingate that allows you to set up a Zero Trust network between your Home Assistant instance, or really anything inside your local network or any network, and a client device or any of your devices. So let's jump right into it and we'll talk about what Twingate is and then how I can set up a quick configuration to talk to my internal network, including Home Assistant. So let's talk a moment about Twingate and what it does. Twingate is a way to replace your traditional VPN and talk to stuff on your local network. It enables organizations to rapidly implement a modern Zero Trust network that is more securable, maintainable than VPNs. It's a cloud-based service, but it allows you to make point-to-point connections over TLS with your infrastructure. It also sets up a defined perimeter without changing your infrastructure, and it can essentially manage user access to internal apps, whether they are on-premise or they're in the cloud. And one of the things we talk about here is the difference between Twingate and a traditional VPN. This is the typical Twingate setup. You have a Twingate controller, which is a centralized web-based management tool. It's a console that allows you to set things up. Then you have an identity provider, and there are a number of them. This one lists Okta, but there's Google and Microsoft and some other ones that are built in to use your own identity provider if you want to. There's also Zero Trust access that allows you to give access to applications from devices, and this limits the blast radius. And in a blast radius, what that means is if one thing gets compromised in a network, it limits it to that one area rather than spreading through everything within your network or potentially even farther than that. So your network itself is invisible to the internet. So you're basically creating a tunnel between your device and your network, and the internet doesn't see that. And then you have split tunneling. Split tunneling allows traffic to pass through the network only if necessary and sends everything else out directly to the endpoint it needs to go to. So if you're doing video conferencing, you don't need it to go over your internal network or your VPN first. It can go directly to the video conferencing endpoint. And so this allows you to do the split tunneling. Now with a VPN, these are some of the issues you have. You have slow connections because all your traffic goes through the VPN. Your VPN gateway is a target. It has to be known on the internet. Everyone knows where it is and it can be attacked. And then you get backhaul traffic. So in the case of a video conference, it all goes to the video or through the VPN gateway and back out again. So with split tunneling that Twingate does, it eliminates that as well. So some other points, basically it's built for IT admins, easy setup, rapid deployment, performance and reliability. So it does all of this without having the infrastructure needed to be in place. Simplifies administrative workloads, effortless for users. You turn it on and it does its thing. Everything is handled at the administrative console. Users just turn on their device and get access to the stuff that they need to get access to. So it's always on, transparent security, easy onboarding, better online experiences. For business, it's better. It reduces costs, reduces risk, and increases agility, and then of course it's future-proof. So let's talk about how we can use Home Assistant with this setup. So you can install Twingate on your local network where your Home Assistant device resides. You can set it up on a Raspberry Pi if you have access to install Docker containers and other stuff via the console. You have to have console access. Now you can do that with Home Assistant. It takes a little bit of work. If you have something like a VM running on Windows where you're running a Ubuntu operating system or some other supported operating system, that's probably a better place to put it. But once you have it set up on your network, you can connect from any device through that local network to your Home Assistant, as long as everything's on the same network segment. Here's some other points to make about this in terms of setting these things up. Your common remote access approach, such as a VPN, you have to set that up. You have to open port forwarding. You have to deal with dynamic IP addresses, fiddle with the configuration of VPN settings on the remote devices, and often requires some sort of paid subscription if you're going to set up a non-open source VPN. With Twingate, on the other hand, there's no VPN. There's no need to use port forwarding. There's a connector that makes an outbound connection that tells everything where it is. No static IP addresses or dynamic DNS, so you don't even have to worry about setting up something to resolve a domain to it. It all can work transparently without that. Remote access client apps for your laptops and mobile phones, and it's free for the non-business account. Now, this page has a whole quick start guide that talks about how to set this up, and I'll link that down below, but I'm going to go ahead and go through it. I'm going to use a Docker container on one of my virtual machines that I'm running within my network. The concept is the same. If you can install this on your Raspberry Pi via a console setup or a console SSH terminal or something like that, then you can run it there as well. So you can have it on your same device as you're running Home Assistant. That is not necessary to use it, but you can do that. All right, so the first thing you're going to do is you're going to create a Twingate account. Once you get an account created and you're signed, you just add a remote network. And you have some choices of type here. AWS, Azure, Google Cloud, on-premise, or other. I'm going to choose on-premise, and I'm going to call it my home network. I'm going to add it. And now I have a home network. And what I'm going to show you is how easy and fast this is. So next thing you're going to do is you're going to deploy connectors. And you have two different connectors here to choose from. I'm just going to choose the first one here. We're going to deploy that connector. And you have choices on the deployment method: Docker, Helm, Azure, Linux, AWS, ECS, AWS, AMI, or manual. I am going to use a Docker container because I already have Docker running on my Home Assistant or on my VMs. So we're going to generate tokens. You need to re-authenticate to generate these tokens. So once I click on generate tokens, it's going to ask me to log in again. And that's what it tells you here. So we're going to authenticate, sign in with Google. That's my SSO or single sign-on provider that I'm using. And once you have authenticated, you will now have your tokens right here. And you're going to use these tokens in a customized Docker command. Okay, so we're going to copy the command. This command is self-contained, including the tokens that you need to have the connector establish a connection back to Twingate servers. We will copy the command. We will go over to our terminal and we will paste that in. So I'll just paste it. Now I will have to do sudo because I am not super user. So I will type sudo. This whole command will do everything you need to get the Docker container installed and running and make the connection it needs to make out to Twingate. So just hit enter. Now it's going to go pull all of the information it needs, all of the images, and now it's up and running. Now, if you're running something like Portainer, you can actually come over to Portainer and see that it's up and running. So if I go to containers here, it is now starting Twingate, and now it's up and running and it's healthy. So now we have Twingate running on our system. And let me take a pause real quick to kind of help you understand a little bit about how this works. Because for me, I needed to understand what Twingate was doing. It's so simple and so behind the scenes and so easy that I was a little concerned about how it works. So I want to take just a moment. We'll talk through how this works a little bit, and then we'll come back and finish the install of this. Okay, so this is the architecture overview. And the reason I wanted to know this, I just mentioned, is I really want to understand how this all works. So it relies on 4 components, and this is helpful to understand when you're creating the different components on the admin console, what they do. There's the controller, clients, connectors, and relays. They ensure that only the authenticated users are able to access these resources. And so what you have here is you have the controller. The controller is the central coordination component for Twingate. It's a multi-tenant component that stores configuration changes via the admin console. It registers the connector. So right now, the connector we just installed, it is now talking to the controller. And it's the only component that does not interact with any data flow. So it has a bunch of responsibilities, and you can read all of this here. The client is a software component that is installed on the user's devices. Its role is to act as the authentication and authorization proxy for requests. So again, that's where it sends, the client itself listens for the requests and sends them where they need to go. All the whitelisting, all the authentication, all of the ACLs are done on the client side. So it does a bunch of stuff: handling user authentication, obtaining a signed ACL, detecting network connection requests to protected resources, and that's where it sends it over to the correct place. Proxying DNS requests. You can have local DNS resolution, or it uses local DNS resolution while it's looking at those resources. Proxying TCP and UDP traffic, and establish a certificate pin TLS tunnel with the appropriate connector. So remember, we just installed the connector on our VM. Now there's a tie into my local network from that connector. The client is responsible for establishing the tunnel with the appropriate connector to access a protected resource. The TLS tunnel is established based on the anonymous unique connector ID and is pinned to the specific connector based on a signed connection token received from the controller. All right, so there's that. And then the connector is the mirror component to the client, but it has a simpler set of responsibilities. So the client connects to this connector. It authenticates and maintains connectivity with the controller. So the connector always, or the client always knows where the connector is. It maintains connectivity with the relays, and it verifies integrity of clients, performs local DNS resolution of proxied requests. So like I said, local DNS resolution is performed by the connector before forwarding traffic to the resolved IP address. So if you have a fully qualified domain name of something inside your local network, it's going to resolve that before it sends it to the IP address inside the local network. And then, of course, the relay is the simplest component. There's no data or network identifiable information stored in the relay, and no data carrying connections are terminated at the relay. It's just a pass-through. It serves as a registration point for connectors and serves as a connection point for clients looking to establish connections to the connectors. And you can see all of that up here on this diagram. So your client goes through the controller, it authenticates, and then it creates a tunnel which goes through the relay and talks back to your connector. And let's assume this is my VM. So that's how all of that works. What I want to do now is continue the setup. If we go back over to our connection status, you can see both the controller, which remember, we talked about the controllers here, and the relay are both active, or they're both connected. And so the next thing we need to do is go back over to our home network, and we want to add a resource. A resource is a thing that you want to connect to within your network. So here's the actual network that we're connected to. This is where the connector is. Now I'm going to add a resource. And this one, we're going to choose CIDR instead of DNS for this one, since we'll be using the IP address. This will be Home Assistant Pi, which is my Home Assistant Pi instance. And the IP address we're going to put in is that right there. And we can add a port restriction. You can enter a single port, a port range, or multiple ports separated by commas. So since Home Assistant is running on port 8123, I'm going to go ahead and put in port 8123 as my port restriction. That prevents anybody else from accessing any resources on this IP address unless they're going directly to port 8123. So not only can you lock stuff down to IP ranges or hosts, but you can also limit stuff to specific ports on the host. And I'm going to give access to everyone for this, because that's the only group I have set up right now. Click on Add One Group, and now we have the Home Assistant Pi resource. And this is a resource that can be accessed when you're connected on this home network, remote network connector. Nothing else in my internal network is exposed through this connector. This is all set up based on the ACLs and everything that are sent to the client when the client connects. All right, let me show you an example of the client. I'm going to show you this on a Windows machine because for the video, it's just easier to do that. It's the same concept on a mobile device. There is an app for iOS, an app for Android, and then there are Windows clients as well. And I'm going to use the Windows client. So let's go over there and do that now. Okay, so here we are on the laptop. And under download, you have a number of options: Mac OS, Windows, Linux, iOS, Android, and Chrome, interestingly enough. I'm going to use Windows today. I'm going to download that, and I'm going to install it. Go through all of the install steps. Nothing really to do here other than just to get it up and running. All right, we're finished. And the first time you run it, it's going to ask you to join a network. So I'll join my network that I created. When we talk about a network, and I probably got these terms a little bit confused, but if we look at this network, this is the network that is connected to this is my home network. This is not necessarily the network we're talking about here. This is the network they're talking about in terms of signing into Twingate on the laptop or a client. So don't get these terms confused. You can call this whatever you want. Their term for network is basically the account. So you're signing into the account. So don't get those two confused like I just did. All right, so we're going to put in my account name. I'm going to join the network. It's going to go through the whole authentication setup or authentication process like we did before. So we'll sign in with Google. And you can see down here that this is turned white because we're connected to Twingate. So every request that we try to send for our Home Assistant that we show right here is going to go through the Twingate adapter. And the way we demonstrate that is I'm going to connect my laptop to my phone's hotspot, so it's not on my local network. And I should be able to get to this non-routable IP address. If it isn't working, I won't be able to get there. Okay, so now I've got my laptop connected to my phone's hotspot. So I'm not on my public, or I'm not on my private network internally. So if I go to a non-routable IP address, my Home Assistant instance, it should take me there. And it does. So I've got to log in, of course. And now I'm logged into my Home Assistant instance on a non-routable IP address. So this resource right here is going through Twingate because otherwise I wouldn't be able to get to it. If I disconnect Twingate, as an example, now I'm logged out of Twingate. If I refresh this page, it should not get to it. And you can see it's spinning up here, maybe hard to see, but it is trying to get to that non-routable IP address. And you also can see down here that it's lost its connection to Home Assistant. So this just proves that without the Twingate connector, it's not going to be able to connect to that particular IP address. So we can add additional resources to this as well. If I wanted to add my Plex server, for example, I would just add that and then the address. And I could do a port restriction as well. Plex is on 32400. And then just add that resource. And I can grant it to everybody. And now I have Plex as available to this as well. So I've got two different resources that are now available internally to this home network that can be reached from Twingate. So you just sign into Twingate, fire it up on your client, and then you're able to access these as well. It's a very simple zero trust network setup to put together and deploy, and it can be done very quickly. I spent more time explaining it than I did actually setting it up, but it's very, very simple. Now, some of the FAQs talks about here what it is, what is zero trust networking. If you don't know what that means, it basically says that you don't trust anybody or anything. And so you only want to let in people or clients or whatever that you actually trust. Because we work in a distributed environment these days, remote workers, you can't come inside and put everybody inside your local network and block everything else out. This allows you to essentially trust nobody, even inside your local network, and then offer resources to them specifically based on what they do. And of course, it talks about how it differs from a VPN. We talked about that a little bit at the beginning. Twingate runs on all of the different platforms. You don't need to have any technical knowledge. What changes do you need to make? Do I have to disable my VPN? All kinds of answers to frequently asked questions here on their website that you can go view at your leisure. Now, there is a little bit different scenario that I'm going to talk about here for a moment. And that is me running something with a local domain. So if we go into this again, I'm going to create one more resource. So I'm going to add a resource. This one's going to be DNS. I'm going to call this local HA. Oops, that's the label. Let's just use local HA. And I will put in the DNS address here. And you can add port restrictions to this one as well. I'm just going to leave it open for now. And I'm going to add this resource. And I'm going to grant it to everybody. So what this will do now, and this is where we talked about the DNS part of this. The architecture overview talks about how this works in general, but let's talk about DNS working. So there's this big flow of how DNS resolution works. And essentially your client will make a connection. It'll come back and be intercepted by Twingate. Twingate then responds with an IP address assigned to the resource, which is this right here. And then the application on the user's device initiates communications with the Twingate IP. So here's the communication with the Twingate IP. The connector receives the connection request, sends the DNS request to the private DNS on the local network, and then the private DNS server responds with the IP address, the private IP address of the resource, which in my case, this particular resource has a local private IP address that my AdGuard server sends back to my client that tells it how to get to this particular resource. And then the connector initiates communication with the requested resource's private IP, proxying traffic through the application's device or the user's device. So there we go. It sends back the request, and then it goes all the way through to the actual private IP address. So when I go to localha.mostlychris.com, you can't get that. That's not resolvable on the public internet. That's only resolvable internally to my private DNS server. So when I put that in my browser after connecting to Twingate, it's going to connect to my local instance. Here's a caveat to things like the Home Assistant companion app. You set a public and you set a private URL, so the app knows which network you are on. If you set local HA or whatever your local thing is, and you set that up here as your local domain name inside your network, your companion app can connect when it's on the local network. And then when you go outside the network, it will try to connect to your public address. If you're running Twingate only to connect to your Home Assistant instance, and you always want Twingate up and running to connect to it, then you would put this as both your public and private in the app. Now, there are ways around that. One of the things you can do is set up an Nginx reverse proxy, and you can put localha.mostlychris.com in your browser or in that proxy and have it proxy back to your Home Assistant instance. You can set it up so that it only allows that from your local IP address range on your local network. That way, if you have the proxy open to the world, it's not going to accept it from outside of your network. If you're using something like Twingate and you're using the app, my suggestion is that you just put the URL for your local instance in your Home Assistant. So let's go in here and let's just do this real quick. If I go back over to my laptop and I type in local HA, first of all, I got to get back on Twingate. So make sure I'm signed into Twingate. So I'm signed back into Twingate. If I put in local HA, because I've got this set up as a resource on my in my system or in my admin panel, so here's the resource, Twingate is going to intercept this URL and send it through Twingate's system to resolve to my private DNS server locally on my network. So let's go look at that now. If I hit enter, it should take me over to my Home Assistant instance, and it does. And so now I'm connected to my Home Assistant instance using the local ha.mostlychris.com. You can see here that I'm on this local HA, which is not resolvable outside of my private network. And actually, Twingate has resolved that for me. That's one way you can use the local resolution, or you can use this to intercept that call to send it through Twingate, and then it resolves on your local private DNS server. And that gives you a zero trust network to connect from anywhere to your local network or your on-premise remote network. One of the final things I want to caution you about is when you're talking about doing this DNS stuff, is not to use a public DNS service to resolve private IP addresses, because you can have a DNS rebind issue. So anything that you have that resolves to an internal address should be run on a local server, like either Pi-hole or even AdGuard, which is what I use. Remember, address resolution of resources is performed from the connector on the remote network that a particular resource is associated with. This means that both local IP addresses and local private DNS names will resolve for remote users connected to Twingate. The only thing you got to be sure of is that when you're doing this, that you can resolve that locally. So if I want to do local HA, it can resolve this IP address. If it doesn't resolve on the machine the connector is running from, then it's not going to work for you. So make sure it does resolve from the connector machine. All right, so that's how you set up Twingate and use it. I made it more complicated than it needs to be in my discussion, but I wanted to give you an overview of the whole thing, from how it works to how to set it up on an application like this, or in an application like this. So if you have any questions about it, let me know in the description or in the comments down below. You can also ask me on Discord. This is just another way for you to connect to your Home Assistant instance from a remote location securely and from a zero trust standpoint. So try it out, see what you think. You can use it up to a certain point for free. So you get 5 users, 2 devices per user at one remote network, the admin API, and a community support forum. If you want to do bigger stuff for business or enterprise, you can do up to $150 users, 5 devices, 10 remote networks, resource level control, identity provider integration, email support for $10. I think this is where I'm at right now in terms of a trial. When you first sign up, you get a trial, and then it goes away and it reverts back to free. If you're just using Home Assistant, then you can get away with the free version. All right, thanks for watching, and we'll see you on the next one.